Hey guys, we are going to take a look at Chapter 7, Lesson 5 today. It's called Indirect Measurement. There's one vocab word, and it is indirect measurement. You can find it, the lesson begins on page 554 in the book. Indirect measurement allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. So one of the ways you're going to use indirect measurement is through similar triangles. As you recall, all three angles of a triangle have to add up to 180 degrees, right? We call that triangle sum theorem. A plus B plus C equals 180. So I had you guys create different triangles, and you remember you ripped off each angle and you rearranged it to form a straight line, which also equals 180, to prove that all three angles of any triangle do in fact add up to 180 degrees. So here's the deal. We have these two similar triangles. They are the same size, but they have a different, they are the same shape, but they have a different size. So we know that this angle is 70 degrees, which corresponds with this angle 70 degrees. This angle is 50 degrees, which corresponds with this angle, also 50 degrees. We don't know what X and Y are, but they have to be the same, right? Because these two are the same. If two angles of a triangle are the same, the third also has to be the same. So if we treated this as our A and our B and our unknown is C, we could write ourselves a little equation, right? 70 plus 50 plus, it doesn't really matter whether you call it X or Y or C, it all refers to the same angle here. I'm going to just call it, how about I'll call it Y, is equal to 180 degrees. Okay, so let's go ahead and combine our like terms. 70 and 50 make 120. I want to get rid of this 120 by subtracting. And so that's going to tell us that y is equal to 60 degrees. And let's check it. Is it true that 70 plus 50 plus 60 equals 180? Well, 70 and 50, that's 120, plus 60 more, 180 equals 180. So it checks out. So you might be asking yourself, well, couldn't I just subtract 70 and 50 from 180? Yeah, that'll work. Either way, you're going to get 60. So this is one of the ways you're going to use indirect measurement today. Okay, so let's take a look at, so this is called angle-angle similarity. By the way, it just says what we just talked about. If two angles of one triangle are congruent, meaning they have the same measurement, the two angles of another triangle, congruent to two angles of another triangle, the triangles have to be similar. If they have, in plain English, if they have two angles in common, they have to have a third angle in common, which means they are similar. Okay, so example 1 here is pretty much exactly what we just saw. I'm going to skip it. Go ahead and look at example A down below. It looks similar, but also kind of different. So there are sort of these two triangles that are connected, and they're only giving us one measurement. So we need to know at least two angles to be able to prove that they are in fact similar. Well, here's the deal. Recall back from, I'm going to say chapter 5, I believe it was. We talked about the idea of vertical angles. Vertical angles are opposite from each other. They have a point in common. They have no common sides. They have the same measurement. So this angle here, I don't know what it is, and I don't have enough information to figure it out, but I know that it's congruent with this angle here. So that's enough to be able to say, yeah, these are similar triangles, because I know that they have three angles in common. I know they have 110 in common. I know these two have to be the same because they're vertical angles. So if they have two in common, they have to have all three. So basically what you're going to say is your proof is that you don't want to say that angle K is congruent to angle K, because that's kind of confusing. So the way you would label that is you would say angle HKJ, which refers to this, angle HKJ is congruent with, let me do a little better job, is congruent with angle LKM or MKL if you prefer. It makes no difference. Angle LKM. So because we're really talking about this K angle, you want to make sure that that's in between. That's the middle, right? Let me, the middle letter is what I'm trying to say here. Let me color code that for you. Right? So at any rate, these two are congruent. So there's your congruent statement for the angles, and then for angles L and H, well, we know that because they're both 110. So you're going to say angle L is congruent with angle H. They're both 110. So therefore, because they have 2 in common, they have to have 3. So our final here is that triangle JHK, or however you want to word these, it makes no difference. The order of the 3 letters doesn't matter. Triangle JHK is similar. So the equal sign with the squiggly above it is congruent. Just the little squiggly here means similar. Okay, is similar with triangle MKL. Triangle MKL. And again, the order of the letters does not matter. Okay, let's change gears here. We're going to look at indirect measurement. One type of indirect measurement is shadow reckoning. 2 objects and their shadows form 2 sides of right triangles. In shadow problems, you can assume that the angles formed by the sun's rays with 2 objects at the same location are congruent. Since 2 pairs of corresponding angles are congruent, the 2 right triangles are similar. You can also use similar triangles that do not involve shadows to find missing measures. So there's a couple of different ways you're going to see these problems. I'm actually going to jump right into, we're going to look at example, I believe it's example B here in a minute. I'm going to have you guys turn the page. But I want to point out to you that the way they're setting up their proportions might be a little different than the way I set up my proportions. So my general rule is I like to put like across from like. So what I do is I make a little list, like fire hydrant and light pole, and then I make sure that I have the corresponding sides across from each other. So for example, the shadow of the fire hydrant is 5 feet. I would have that across from the shadow of the light pole, which is 26 feet. Okay, I would put the height of the fire hydrant, 2.5 feet. I would put that across from the height of the light pole, which is the unknown. We're trying to figure that out. So we're basically, for whatever reason, we really want to know how tall this light pole is. It's really hard to measure because it's too tall. But basically what we're doing is we're using indirect measurement. We're using the height of a shorter object as well as the shadow it casts, and we're comparing it to the unknown height of the taller object and the shadow it casts. So it's easy to measure a shadow, right? If you have a measuring tape, you can measure a shadow. Not so easy to measure a tall object. So you're just going to set up a proportion where you go ahead and cross multiply and divide to figure out that missing height. So you're going to see they set it up slightly differently. They put 5 across from 2.5. So they're saying, hey, they're putting the hydrant's measurements up top and the street light measurements down below. It's going to work out. Just to be consistent with what I've done in previous lessons, I'm not going to model this way. I'm going to model a slightly different setup in terms of writing my proportion. And I'll show you that in example B. So let's look at example B, and then we'll come back to the last example 3. Okay, so it says at the same time, a 2-meter street sign. Let me color code all this. A 2-meter street sign cast a shadow that's 3 meters. Okay? A nearby telephone pole casts a shadow that's 12.3 meters. How tall is the telephone pole? So that's the unknown. Okay, here's our sun. I drew the sun over here. Anytime you get one of these word problems, I really find that it helps to draw it out. And, you know, if you even just wanted to draw 2 right triangles, they don't necessarily have to be, you know, have the actual things from the word problem in them. But I find that it really helps me visualize what's going on here. Okay, so what I did is I made 2 little columns here. I have a column for the sign, and I have a column for the pole. So the height of the sign I know is 2 meters. It corresponds with the unknown height of the what is this, a telephone pole. We don't know. We're calling it X. Okay, so then down below I put the shadow. The shadow of the sign is 3 meters. And the shadow of the telephone pole is 12.3 meters. Okay, so I'm just going to color code all this so you guys can see clearly where it's coming from. The height, 2 meters, is going to correspond with the height of the pole, which is unknown. The shadow of the street sign, 3 meters, is going to correspond with the shadow of the telephone pole, which is 12.3 meters. So setting up the proportion is probably the more difficult part. Once you guys get to the proportion, this is easy. This is like 6th grade math here, right? So you're going to go ahead and cross multiply. 3 times x is 3x, right? And we're going to go ahead and cross multiply 2 times 12.3, which is 24.6. 2 times 12.3, which is 24.6. You're going to undo what's been done to x, which is being multiplied by 3. You're going to do the opposite and divide. Running out of room, like I always am. Divided by 3, that is going to tell us that the height of the telephone pole is 8.2 meters. X is equal to 8.2. 8.2 meters. Okay, so there's one more way that we're going to look at indirect measurement. So I'm going to actually go back to example 3. And you're going to see basically in this situation, you're going to see kind of a shape inside of a shape, a right triangle inside of another right triangle. So it's the same concept but slightly different. So let me color code this for you guys so you can see it. There is a larger right triangle. Okay, so I'm going to make my list here. I'm just going to call it large and small. So let's see here. Of the dimensions of the larger right triangle, let's say, so there's going to be the hypotenuse, right? And then there's going to be, we know the dimensions of the leg, of one of the legs. We're looking for the dimension of the other leg. So by the way, let me back up here. So in the figure at the right, triangle DBA is similar to triangle ECA. Ramon wants to know the distance across the lake. So he's using these 2 right triangles. He knows that from the distance from B to D is 40 meters. So he's trying to figure out what the distance from C to E is using these 2 right triangles. So there's the hypotenuse. I'm just going to abbreviate it. Hypotenuse. And then, you know what, I'm going to shift all this down because I just don't have enough space. Hypotenuse, and we're going to call it the leg of the other dimension, the shortest leg. And again, there's the, let's put small, the smaller triangle and the large triangle. Okay, so let's see here. Of the small triangle, I know that the hypotenuse is 320. And I know that the leg here is 40. Okay, is equal to, so let me kind of started color coding this in a different way. So I wanted you to visualize, hey, there's this larger triangle, and then there's a smaller right triangle, which is right here. Okay, so I'm going to put, how about I put the hypotenuse in pink, and I'm going to put, how about the leg in orange. The leg in orange. Okay, so we know both dimensions for the small. We know the hypotenuse is 320. We know that the leg is 40. We're looking for, in the large triangle, the larger right triangle, we're looking for the leg. So we're going to call this D. So here's what's interesting. What's the hypotenuse? People are going to say, oh, it's 162. Well, it can't be, because it's got to be larger than the hypotenuse of the smaller right triangle, which is 320. You actually have to add these two distances. So if you add 320 and 162, 320 plus 162, you're going to get 482. So you have to add these two up. Okay, grand total 482. So that is the hypotenuse of the larger right triangle. So let me put that in pink. Okay, 482. So this is now exactly the same, right? It's the same. You're going to cross multiply. You're going to divide. You're going to see that they set up their proportion a little differently, I believe. But it's going to, as long as you're consistent, you should get the same result, right? So what you can't do is you can't put the hypotenuse of the small over the leg of the large, right? That you can't mix up. So that's why I really recommend labeling. I have my smaller right triangle. I have my larger right triangle. The numerator represents the hypotenuse. The denominator represents the leg. Okay, so I'm going to go ahead and let's see. 320 times D is 320D is equal to 482 times 40 is equal to 19,280. And then we're going to divide by 320. Divide by 320. And we're going to get 60.25, which is exactly what they got. Right? So set up my proportion a little differently. Like I said, you do have a little bit of flexibility. You just have to make sure that you are being consistent and that you're putting like across from like. All right, so that's pretty much it for the lesson. There are a couple of homework problems that I would like to help you guys out with. First of all, number 2, this is where you're saying whether the triangles are similar. So you're going to write the angle congruent statement, and you are going to, write your final triangle similarity statement, just like we did with example I believe it was example A. Here's the deal: is this is a scenario where you have a smaller triangle inside of a larger triangle. Well, we know that angle B and angle D are 30, right? We don't know what A is. We don't have enough information to figure out what A is. What about F and C? Well, to me, these sort of look like corresponding angles. So that corresponding angles, if you go back to chapter 5, they're on the same side of, if you treated this as a transverse, they're both on top of, if you treated these as parallel lines. We know that these two are corresponding. I don't know what they are, but I know they're the same. They have the same measurement. So you're going to go ahead and write congruent statements saying that angle B corresponds with angle D, angle C corresponds with angle F, angle A has to be this, it's literally two triangles are sharing the exact same angle. So that would even be enough information to say. You know they have B and D in common, they're both 30 degrees. You know they have to have angle A in common because they literally share that angle. Because they have those two in common, they have to have a third in common. Okay, I'm going to let you guys handle 3 and 4. Pretty doable. 5 is a little tricky. So they want you to say what the distance is from the log ride to the pirate ship. So there are 2 similar triangles here. So I have my list, right? Here's my smaller triangle. Here's my larger triangle. You want to make sure that of the smaller triangle, you're putting the longer distance, 12 meters compared to 8. 12 is longer than 8, right? 12 has to correspond with the unknown distance here. Whoops, that's the wrong color. Blue. Okay, and that the shorter side of the smaller triangle, which is 8 meters, has to correspond with the shorter side of the larger triangle, which is 25. Oops, it should be in orange. Just like that. Okay, so I'm going to let you guys handle that. 6 is very similar to examples, I believe it's example 3 that we just talked about. You're, in this case, so here's the deal. It's similar, but it's a little bit different. So we know that the leg, let's make a list here, small right triangle, large right triangle. So leg, hypotenuse. So smaller it's actually not the hypotenuse this time. It is, there's a longer leg and a shorter leg. So I'm going to back up here and call it longer and shorter. They're not giving us the hypotenuse. So let's say longer, shorter. Because they're both legs. So if I call them both legs, it's not going to be helpful. Okay, so let's see here. Of the smaller, one of the legs is unknown. We're calling that H, right? The other leg is 7 feet. Is equal to. Okay, so what's the unknown height gonna correspond with? Well, it's the shorter of the 2 legs of the larger triangle. So that's going to be 9. Here's what's curious is in the last example, you had to add up 2 distances. Let me go back to that. You had to add up, this is example 3, you had to add up the 320 meters to the 162 to get the grand total. If you look at this figure here, it's not the same. They're telling you from here to here is 7. From here all the way to here is 15. So in this case, you're not going to add up the 15 and the 7. They're flat out telling you this distance is 15 and this distance is 7. So in this case, you're not actually going to add. You're just going to say that this is the distance. 15 feet should be the distance. Okay. I think that's, okay, so the last one I'll kind of talk to you guys about is 7. It's pretty doable. I went ahead and I just drew it out for you guys to help you visualize. There's a Ferris wheel. It's 136 feet tall. It's casting a shadow that's 34 feet. There's a guy. We don't know how tall he is. His shadow is 1.5 feet. So I went ahead and I made my list. The guy, the Ferris wheel, the shadow for both have to correspond. The height for both have to correspond. So I'm thinking that's pretty much it. The rest of this should be pretty doable for you guys. Okay, just FYI, I did go ahead and make an alternative homework assignment in connected.mcgraw-hill.com. You do not need to do both. I've been getting a lot of emails. If I do one, do I have to do the other? No. If you want to continue on doing the book work, that's fine. Or you can log in to connected.mcgraw-hill.com and you can take the homework quiz and I will give you homework credit for that. So it's an either or situation. It's not both. All right, I hope that helps. If you have any questions, then you can see me tomorrow during my Zoom meeting from 11 to 11:30. All right, take care, guys.